And I will be sharing my screen now. Okay, so I've prepared some slides for this because this part is, a bit theoretical. We will be discussing a few definitions and then I will be writing wherever needed. Acha, I've shared my screen. Can anyone confirm if you guys are able to see my screen or not?
Yes, we are able to see
The screen. Okay, great.
Yeah.
Thank you so much. Okay. Now, let's talk about the definition of sets. A set is a collection of well-defined, distinct objects. Okay. So basically, we would be talking about a few sets which would be well-defined. Matlab ke whatever elements we would be having in that set would be through a definition and would be distinct. For example, I can write down the set of even numbers between 1 and 11. Okay, so the set of even numbers between 1 and 11 would be 2, 4, 6, and 8, right? These are the 4 elements which I would be having in the set of even numbers between 1 and 11. So I have followed the definition and I need to make sure that all the numbers, all the elements written in this set are distinct, means they must be different. Okay? It's just a basic definition that we will be making sets through a definition. Inshallah, it would be clear once we talk about the examples. And we must have different elements in the set. You cannot have 2 times 2. For example, I cannot have a 2 here. If I have 2 coming 2 times, that would be wrong. Okay, so it means we cannot have any repeated element here. All right. Okay, let's read further. Then it says, the objects of the set are called elements. You can have different numbers in a set. You can have A, B, C, D. We'll be talking about everything. We call them elements. Okay. Sets are denoted by capital letters. Okay. Now this is basically a set A. It has 1, 3, 2, 5. We use curly brackets to write down the elements in the set. And this n bracket A means the number of elements in the set A. We have 1, 2, 3, 4 elements. That is why it is 4. So far we know, in order to write down a set, we use curly brackets. These are the curly brackets. These are the curly brackets which we are using. Then we have commas here. Every element is separated, and in total we have 4 elements. So n of A is basically a way of writing down the number of elements in A, and that is 4. Okay. One last thing, we will be talking about this again and again, so you would understand it easily. We can see that the set A has a 3. So you can write it this way as well. 3 belongs to A. This sign is basically belongs to sign. And since 3 is present in A, so we can write it as 3 belongs to A. And then 7 does not belongs to A. So you will make the belongs to sign and then a line on it means does not belongs to A. It means 7 is not an element of A. Okay. So this is a basic definition. It's completely fine if you were not able to understand a definition well. In maths, we apply things, we don't learn stuff, right? So we will be talking about some examples, it would become clear. Okay, let's talk about some examples and then you would get the idea. Acha, the set could be of any type. The set could be of any type. It could be of even numbers, odd numbers, vowels, English alphabets, prime numbers, composite numbers. It could be of any type. Okay, so let's look at some examples of sets. Set of even numbers between 1 and 15. Now, yesterday Kabir was there in the class, so we studied what is an even number. An even number is a multiple of 2 between 1 and 15. So we know we would be having 2, 4, 6, 8, 10, 12, 14. Okay, so how many elements do we have in this set? 1, 2, 3, 4, 5, 6, 7. Another example, the set of numbers divisible by 3 between 1 and 20. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Acha, 1 and 2 are less than 3, so obviously they would not be divisible by 3. 3 is divisible by 3. 4 is not divisible by 3. 5 is not divisible by 3. 6 is divisible by 3. And why am I saying this? We have discussed all the content in yesterday's class. If a number is coming in 3's table, we know 3 comes in the table of 3, 6 comes in the table of 3, 9, 12. All these numbers are coming in the table of 3. It means that all these numbers would be divisible by 3. 9 would be divisible by 3, 12 would be divisible by 3, 15 would be divisible by 3, and 18 would be divisible by 3. So we need to be careful that we need to stay between 1 and 20. So it would have 3, 6, 9, 12, 15, and 18. Any confusions, any difficulties so far? Please tell me. If you were not able to understand anything, I can explain it again.
No, ma'am, I understood.
Okay, very good. Okay, what about Muiz? Yes.
Understand.
Okay, thank you.
Understand.
Okay. Umayza, are you good with this? And Subhan?
Yeah, I am.
Okay, thank you. All right, now even though we're studying maths, but set could be of anything, right? So set of vowels in English alphabet. So it is A, E, I, O, U. These are the vowels, right? Okay. Let's talk about some more examples. Okay, we are done with the first one already. We have done the first one. Let's talk about the second one. Set of all odd positive integers less than 10. So we are talking about all the odd and the positive integers less than 10. So it would be 1, 3, 5, 7, 9. Okay. If I talk about the number of elements in O, this is the notation. And how many elements do I have? 1, 2, 3, 4, and 5. So I have 5 elements. Okay. Set of all positive integers less than 10. Now it says all positive. It could be, or it could be even less than 100. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100 till 100, right? Like we would be having this dot, dot, dot means all the numbers between 3 and 99. And this is going to be the set of all the positive integers between 100. Okay. Let's talk about, yes, this is basically the second chapter of the O-level math syllabus. Now we won't be following D1, D2, D3, D4. Yes, the chapters are same, but in the first class, we discussed the syllabus. We have 42 chapters in total. The first chapter was numbers. We are done with that. In numbers, we discussed LCM, HCF, prime factorization, divisibility rules. I'll be sharing the recording. So inshallah, you all would be clear with that. And the second chapter is of set. So we are following the syllabus present on the website. Okay, definitely. I just need 1 minute. I'll scroll up. Some students joined later, so I need to show that as well. In the first slide, basically, we just discussed the definition of sets, okay? A set is a collection of well-defined, distinct objects. So there would be a definition, and you need to be sure that every element is different from the other one. They must be distinct, okay? Then how do we write down sets? We write down the elements. We call them elements, and we write them down in curly brackets. This is the notation used to define the number of elements in that set. This basically is the symbol that shows belongs to. Since 3 is there in A, so we can write it as 3 belongs to A. Since 7 is not there in A, so we can write it as 7 does not belongs to A, right? So we only discussed the definition. It's simple. Definition says collection of well-defined objects. Then we are writing down the elements or the objects of the set in curly brackets. In order to write down the number of elements, we are writing it down as n and then the name of the set in brackets. This is the belongs to sign and this is the not belongs to sign, right? We will be talking about the entire notation at the end once again. Okay, is it okay, Miza?
Yes, it is.
Okay. All right, great. Okay, so, and the last set was the set of all integers less than 0. So we have discussed this as well. This is the number line. This is 0. Here we have positive numbers. Here we have negative numbers, -1, -2, and so on. Less than 0 means we would be starting off with -1, and we will be going till the end of the number line. And we're not sure about this number because in maths we can write down every number, right? So the last number is considered to be infinity. That is the world's biggest number, but we are not sure about it because, you know, we have 1 billion, 1 trillion, 1 zillion. We are not sure about when it is ending. It keeps on going till infinity, right? So in short, at your stage, just know that a set has a definition and you need to make sure the elements present in your set must not be repeated. You need to have the collection of distinct objects. Yes. Okay. All right. Acha. Okay, let's talk about this now again. Now we have formally defining everything. Naming sets and number of members in a set. Usually we use capital letters to denote a set and small letters to denote the members of set. Okay, so we have discussed that already. This set is capital A, this set is capital B. Then this indicates the total number of members slash objects slash elements in the set. So number of elements in A is 1, 2, 3, 4, 5, 6. That is why we have a 6 here. And then number of elements in the set B, 1, 2, 3, 4, right? So this is how we define the number of elements in any set. Okay, this is good. All right, now again we have the symbol. This is an element. It means belongs to. Okay, this symbol right here means that, for example, if I am talking about this, right? So I can write it as 3, this sign and A. It would mean 3 is a member of A, or 3 belongs to A. This E type of symbol basically means belongs to. Belongs to. If there is an element in the bigger set, you can write it as that element belongs to the bigger set. And this is not an element. So for example, I can clearly see I have 1, 3, 5, 7, 9, 11. If I talk about 13, जैसे इधर बात हो रही है 13 की, so I can write it as 13 does not belong to A. Okay, so this symbol is does not belong to. Okay, this is how we define belongs to and does not belongs to. Any confusions here? Is it good? Are we good with this as well?
Yes, ma'am, I'm good.
Okay.
Good.
All right. Okay. Very good. Okay, now we have two types of sets. We can have a finite set and then we can have infinite sets. A finite set would have finite elements in it. When we say finite, it means countable, like it would be something that we can count. And infinite means a very, very big number which we cannot count. Okay, so for example, 1, 2, 3, 4, 5. A has 5 elements. It is a finite set. B says days of the week beginning with T. Now here, they did not write down the elements of the set. They have just used a description to explain. And it says days of the week beginning with T. So we know it would be Tuesday and it would be Thursday, right? So these are the two elements of this, and the number of elements in this set are 2. So these are two examples of finite sets. Let's talk about some infinite sets now. Here they are. Okay. Now, sets in which it is possible to list all. Okay, all right, there's something wrong in the definition. Sets in which it is not possible to list all the members of a set. Infinite set means sets in which it is not possible to list all the members of a set. For example, if we want to talk about all the even numbers in maths, 100 is an even number, 1000 is an even number, 10,000 is an even number, 1 lakh is an even number. You can go on till infinity. So you're not sure about that last number, so you cannot list all these now. That is why it is considered to be an infinite set. You can talk about the set of odd numbers as well, right? If we talk about the set of odd numbers in mathematics, all the odd numbers, that would be infinite, okay? Can anyone give me some other example of an infinite set in mathematics? You can make up the set by yourself, it's completely fine.
Like the number of hair, that's the same thing.
Yes, sorry, please say it again.
Never mind.
You can just type set of odd numbers. Very good. Can you show the first page? Okay. All right. If we stick
number
to
of stars.
yes,
The number of stars.
okay, very well done, excellent. We know that we have infinite many stars. So if we start writing down all the stars, that would be infinite. Very good. Then if we talk about mathematics, so you can say the multiples of 3. We have infinite many multiples of 3. We have 3, 6, 9 till 30. Then 90 is also a multiple of 3, and so on. 999 is also a multiple of 3. 18, 18, 18, 18. These are also this is also a multiple of 3, and so on, right? So we have infinite many multiples of 3. You cannot list all of them, so it is an example of infinite sets. Yes, very good. Well done. Number is divisible by 0. Okay. Don't worry, Kabir. I'll explain it to you. Achha. You know what a set is? A set can be defined in any way, whatever way you want to. It could be vowels, it could be odd numbers, it could be even numbers, it could be the set of stars in the world, it could be anything. It could be the set of cars, you know, that Mercedes is making. It could be anything. Okay. Now, when we talk about sets, we have two types. One is finite, the other one is infinite. When we say the set of even numbers less than 10, we have 2, 6, 2, 4, 6, 8. We only have 4 elements. That is finite. Whenever something is countable, that is finite. Whenever something is uncountable, you cannot count all the stars in the world. You cannot count all the odd numbers in maths. You cannot count all the natural numbers. We have discussed the set of natural numbers, right? So we know all these are examples of infinite sets. Any confusions now? Yes.
No, ma'am, understood.
Okay, all right. So Bhan, are you good with it?
Yeah, man.
Okay, all right. So those who were not there in yesterday's class, please watch the recordings. Every query would be clear. We have discussed natural numbers there as well. It's very easy. You need to watch the recordings only. It is not used that much here. See, I'm not focusing on that part. For sets, we can just, you know, talk about the other examples as well. All right. Okay. Now, relations of sets. Universal set, the set which contains all the elements. All proper subsets formed within the universal set draw their elements from the available elements of the universal sets. Okay, one second. I'll explain to you. Don't worry. Okay, let's talk about this one. Acha. Abhi tak, we were talking about sets individually. For example, we were saying set of odd numbers, set of even numbers, is tarah se, theek hai? Abhi tak we were just defining sets. That is it. Now, when we will be talking about the past paper questions, there you will see we will be talking about universal set, complement of a set. What exactly is happening there? Acha. In past paper questions, we won't be using infinite sets. Is tarah ka kuch bhi nahi hoga. We would only be focusing on one big set. One big set is the universal set that is going to have finite number of elements, and then we would have subsets of that bigger set. I'll tell you what exactly I am saying. Okay, think about this as example number 1. This is example number 1. Now saying that this is the exam stuff, okay? This is a universal set. Yes, yes, yes. I can repeat, don't worry. Universal set is basically a big set that has small sets, okay? In the exam, you would be given with the universal set and the smaller sets, and then we would be doing further things over there. For now, we were just discussing the basics of sets, okay? Universal set is a big set that would be having finite number of elements. For example, let's think about this as the first example. This is the universal set. It has 2, 3, 5, 7, 11, and 13. And then you have a subset of the universal set. When I say subset of the universal set, it would be another set having some elements of the universal set. Okay, A has 2, 2 is there as well. It has 3, 3 is there as well. It has 7, 7 is there as well. And then 13, 13 is there as well. Okay, so this is how we define the universal set and then a subset of the universal set. Okay, the universal set could be of any type. Okay, for example, here in the universal set, we have 2, 3, 5, 7, 11, 13. I will talk about the second example and then you will see the universal set could be of any type. Okay, this is just one scenario. For now, we are focusing on what exactly is complement of a set. Please focus now. Universal set would be the bigger set. A would be the smaller set. Okay. In order to find complement of the set A, we will be talking about all the elements present in the universal set except the elements of A. I'll repeat. Complement of A means all the elements in the universal set except the elements of A. Forget about what universal set is, what A is. You can see two sets in front of you. This set is the universal set. This is the set A. We are talking about A complement. We write it as A dash. How are we defining it? A dash or A complement has all the elements of the universal set except the elements of A. Let's see. Now I'm interested in defining the complement of A. So I will be crossing out the elements of A from the set from the universal set. Okay. So 2 would not be there because I'm interested in all the elements of universal set except A. 3 would not be there. Then we have 7, 7 would not be there. Then we have 13, 13 would not be there. We are left with 5 and 11. So A complement is going to have 5 and 11. Okay. Forget about everything we have been discussing so far. That was just an idea for you guys to get comfortable how exactly a set looks like and some basic stuff. This is the major content. If you were not able to understand what a universal set is, forget it. Bhul jao. That is not needed. It would get clear automatically. Just know we have two sets here. This is the universal set. This is the set A. If you're interested in finding out A complement, we will be crossing out the elements of A from the universal set in order to get the complement of A, and we are left with 5 and 11. Any confusions here? Please tell me if you are good with it or not.
No, ma'am, I'm good.
No. No.
No.
Okay, all right. Okay, thank you so much. Acha, now I have a question. What is the difference in A and A complement? Okay, A would be given, this set A would be given in the question. A complement, you will be finding A complement would have all the elements of the universal set except the elements of A, right? So they are completely opposite, completely opposite. A and A complement would have totally different elements. They would not be having same elements. Okay, perfect. It's good now. All right, let's practice this stuff more. Then we'll talk about the next thing. I will just clear this and I will make an example of my own just so we can practice. And then we'll be talking about the next stuff. Okay. Now imagine you have a set B. Okay, we can have set A, set B, set C. Name does not matter. We have a set B. And again, the question is about finding B complement. These are the curly brackets we use. This time around, I can define universal set any way the examiner can give you anything in the universal set. It is completely fine. Let's write down 1, 3, 5, 7, 9, 11. Okay. And then in the set B, I'll write down 2, 4, 5, and 7. And now I'm interested in finding out B complement. Students, what is B complement? B complement is written as B and then a dash. You can write the dash this way, you can write the dash this way. That does not matter. It's just a dash on top of it. B complement is going to have all the elements of the universal set except the elements of B coming in the universal set. Okay, so we have 1 would be coming in B complement because we do not have 1 in B. We have 3 would be coming. Then we have 5, but 5 is there in B as well, so I will be cancelling out 5. I'll be cancelling out 7. Then we have 9 and 11. So I need to write down 9 and 11. The next one would be 9 and it would be 11. So these would be the elements of B complement.
Ma'am,
Yes.
there's why is there 2?
We can have 2. Okay. Yes. One second. Yes. This is because, one second. Let me write it again. Thank you so much. I had a 2 under it, so I don't know why I wrote it. Okay, we have 5 and 7 only. Okay, thank you so much for mentioning this thing. Okay. Very good point. Now, in the universal set is the big set, and the small set would be having the elements coming from the universal set, right? In order to define the complement of a set, we need to cross out the elements coming in the universal set which were coming in B as well. Okay, let's talk about one more example and then that is it. Let's say that the universal set is the same. I will be defining this a bit differently now. So you guys need to do this example, okay? All right, everything is clear. I will just erase something from here and here. Okay. Now tell me, what elements are we going to have in the A complement? Yes. What would be the elements in A complement now?
5, 7, and 11.
5,
Excellent.
7, and 11.
Very well done. Very good, all of you. Very good. So we have 2, 3, and 13 here. I'll cancel 2, 3, and 13, and we are left with 5, 7, and 11. Very good. Okay. So this is how we define complement of a set. I hope we are good with it. Universal set would get clear once we talk about a lot of examples. Okay. This is the first most important concept. Okay. Let's talk about the second one. The second one is intersection of sets. Intersection of sets is denoted this way with a U that is other way around. Okay, this is the sign of intersection. Now you would be having two sets, set A and set B. And in order to find out A intersection B, we will be talking about the common elements. Okay, so I need to talk about the common elements in A and B. 2 and 2 is common. Then 4 and 4 is common. Rest of the elements are different. It means I only have 2 common elements, 2, 4, 2 and 4. These are the common elements. So I will be writing down the common elements. Intersection basically means common elements in the two sets. Okay. So we have 2 common elements in these 2 sets. So the set of A intersection B would be 2 and 4. Acha. I'll talk about another example here so it would get clear. Now we do not have that universal set here, okay? Now it is just 2 sets given. You will get comfortable with universal set in some time. Acha, imagine you have 2, 4, 8. Then we have 10 and imagine we have 6 as well. Okay, now what would be the set A intersection B? We would be having the common elements. So 2, 4 and 6, right? So we have 3 elements now, 2, 4 and 6. Intersection would always mean common elements coming in common in both the sets. Any difficulties here? Any confusion?
No, miss.
Okay, so we are good with complement and intersection. All right, let's talk about union, okay? The union of set A and B is the set of all the elements in A and B, or in both A and B. It is denoted by this. Acha, listen to me, please. Union is denoted with a U, okay? Now imagine you have 2 sets, A and B, okay? So A and B are the 2 sets here. And if you are interested in their union is self-explanatory. We will be talking about all the elements of A and all the elements of B, okay? So it would be 1, 3, 4. We are done with the elements of A, and it would be 6, 7, 8. We are done with the elements of B, okay? A union B is a set, and A intersection B was also a set. I have another example for you. Let's talk about another example here. So imagine A has 1, 2, and 3, and then set B has 1, 4, that is it, okay? Now if I ask you to write down the set of A union B, can anyone tell me what would be the elements in A union B?
1, 2, 3,
1, 2,
4.
3, and 4.
1,
1, 4.
1, 2, and 3, and
4.
very
1,
well
4.
done. Okay, I'll tell you. Excellent. We would not be having 1, 4 here. Very good job. I'll tell you why. We would only be having a 4 here, and I know we have a 1 here, but we have written this 1 already. If I write it down this way, the way some student was saying, 1, 2, 3, 1, 4, the issue would be that in the very beginning, we discussed the definition of a set, which said we need to have distinct elements. Agar 1 2 baar aa raha hoga, to the elements would not be distinct. So technically, this cannot be a set. Ye definition kharab ho jati hai. Isliye we know whenever we are supposed to write down the union, agar to koi element repeat ho raha hai, we are going to write it down once only. We would not be writing it down again because that would violate the definition of a set, right?
Yes, ma'am, got it.
Okay, let's talk about.
Understood.
Okay, I'll just talk about one more example because this is important. Okay, now imagine we have set B as 3, 4, and 5. Yes, please write down. You can either just tell me or unmute. A intersection B and A union B. Yes. What would we have in A intersection B? This is A, this is B.
3.
Very good. Intersection means common elements, okay? So this 3 and 3, only this number is common. So it would have 3 only. We can write it in these brackets. And when we talk about A union B, we will be talking about both A and B. So how are we going to define this?
1, 2, 3, 4, 5.
Well done, Umaiza. Excellent. Very good. 1, 2, 3, 4, and 5. We did not write 3 again because that would violate the basic definition. Okay. All right. Okay. Okay. We will be discussing Venn diagrams in detail on Monday. Venn diagram is basically another way to represent sets and the universal set. Now again, this is going to be the universal set. The elements in this rectangle would be the elements in the bigger set, in the universal set. Then this A would be this set, and then this B would be this set, right? We will be talking about Venn diagrams in detail on Monday. So everything would be clear there. Let's talk about one last thing for now. Acha. So we know that sets are defined using these curly brackets. For example, A is a set, B is a set, C is a set. It would be collection of objects, and we need to make sure that we have distinct objects. Okay. We cannot have repeated objects. Okay. This means intersection. So A intersection B would have common elements. 3 and 3 are common. That is why we have this. Union means it should have the elements of A and B both. So we will be writing it down as 1, 2, 3, and then 9. We cannot write down this 3 again because that would just violate the definition of a set. Okay, then let's just talk about, I'll just erase the other one because that would confuse you. This is not needed for now. Okay, all right. This is the symbol for proper subset. A subset is basically a set that is lying in a set. For example, A ke andar I have 1 and 3. Okay. If I want to talk about the subsets of A, 1 would be a subset of A, this 1, right? This 1 can also be written as a set and it would be subset of A. Then if I talk about B and C, set B has 2, 3, 9 and C has 3, 9. So I can write it this way. Since C has the elements of B, so I can write it down this way. B is a subset, C is a subset of B. Okay. Are you clear with the idea of subsets?
Yep.
Yes,
No, miss,
ma'am.
can you repeat it?
Okay. I will repeat it again. Okay, no problem. Okay. Okay, let me just erase this part as well. We just have subsets for now. Okay. So we are focusing on subsets only. A subset is denoted using a C. What does it mean? इसका मतलब ये है कि आपके पास एक बड़ा सेट है और एक छोटा सेट है and that छोटा set is lying in that bigger set. ठीक है? For example, let's just talk about this one. We have set B that has 2, 3, and 9. We have set C, it has 3 and 9. So set C is a subset of B because this 3, 9 is lying in B as well. Okay? B is the bada set for this scenario and C is the smaller set. Since the smaller set is lying in the bigger set, that is why you can say that C is a subset of B, right?
Is a B a universal set?
No. Forget about universal set. Universal set is only denoted this way. Universal set को आप ऐसे denote कर सकते हो, but subsets can be, you can have subsets of any set in maths. ठीक है? Subsets किसी भी set के हो सकते हैं, किसी भी set के subsets हो सकते हैं. ठीक है? Universal set के भी subsets हो सकते हैं, किसी और set के भी subsets हो सकते हैं. For now यहाँ पे हमने कहीं भी universal set की बात नहीं की. ठीक है?
Okay. ये सबसेट के सबसेट हो सकते हैं?
हाँ, एग्जैक्ट बिल्कुल हो सकते हैं. फॉर एग्जाम्पल C is a subset of B. ठीक है? अब अगर मैं कहूँ, let's talk about a set containing 3 only. A set containing 3 only. So this would be a subset of C. ठीक है? A set containing 3 only would be a subset of C. तो किसी भी set subset के further subsets हो सकते हैं, right? Is it okay?
Can A be a subset of B?
नहीं, नहीं. A cannot be a subset of B because A के अंदर we have 1 and 3 B के अंदर we do not have 1. अगर तो B के अंदर 1 होता तो in that case I would have said कि A is a subset of B. But since A completely B के अंदर lie नहीं करता, I only have 3, so I cannot
Yeah,
say
we
A
don't
is a
have
subset.
one.
Yes. Yes, please ask me more questions. Anyone else? Acha. And then the last thing is, this is not needed, and then this we'll be talking about it later on once we talk about more topics. And this is what we discussed in the beginning. It means belongs to. So since 3 belongs to A, you can write it as 3 belongs to A. This side is basically the belongs to sign, and then this sign is basically does not belong to sign, right? So since 4 is not there in A, so I can write it as 4 does not belong to A. Okay? Any confusions, any queries? You're more than welcome. Ask me right now.
No, ma'am. I have understood.
Okay. And what about the other students? Please feel free to ask me. Harun, Moi, Subhan, Umaiza, and Urva.
Crystal clear.
Okay. All right. Okay. So 1 second. Okay. Great. So I'll stop sharing the screen. I'll stop the recording.